The Mark Thompson Show.
This guy I used to speak to in the 80s when I was doing KGO radio. And whenever I would do KGO, I would always try to get him because I thought he was just the greatest ambassador for science and for astronomy. And sure enough, in all the years in between, he's retired as the chair of astronomy at Foothill College, but he teaches introductory astronomy at the Fromm Institute at University of San Francisco. He's the lead author of the most frequently used basic astronomy textbook in the country. Astronomy was published free online by the nonprofit OpenStax project at Rice University. This is an effort to make all textbooks free. As you know, it's a huge encumbrance often to buy these different textbooks. And our guest was instrumental in getting this astronomy book published for free online. He published 7 science fiction stories based on solid astronomy. The International Astronomical Union has named asteroid 4859 asteroid Fraknoi to recognize his contributions to the public in the appreciation of science. Please welcome him now, Professor Andrew Fraknoi, everyone. Yeah. How are you, sir?
Well, thank you for that very generous introduction. I'm delighted to be with you.
You are well deserving of it. And I'll tell you something else I used to say, Kim, about Andrew Fraknoi. There was Carl Sagan was the big astronomy and cosmos voice for explaining stuff back when in the 80s, really was when I was first interacted with Professor Fraknoi. And I said, the Bay Area has a Carl Sagan. It is Andrew Fraknoi, without question. You have that ability to communicate these ideas, some of them very important, some of them very complicated, and you haven't lost that. So I used to listen to you when you were on Pat's show, and I was green with envy that I felt like you were, she had kind of claimed you as we were all on KGO. So again, now my effusive affections, I'll try to put them to the side for a moment. We can get on with things. Big announcement, Professor Fraknoi, and that is Jupiter they just discovered 12 more moons, I saw.
And a major announcement from the Mark Thompson Show. A major announcement.
Well, it is sort of a major announcement because it makes Jupiter it has more moons than any other planet in the solar system, right?
That's correct. And we're getting into the 90s, which is an amazing number of moons.
What?
For a planet like us that only has 1 moon, we're green with green cheese envy about the moons of Jupiter.
92 moons. And
this
and
is Casey
exactly
Kasem
right.
on American Top 40 in Hollywood.
That's right. Jupiter moving up to the top position with 92 moons. Now, moons, I'm learning, though, as I look at the Jupiter situation and that announcement, I was just reading some of the articles about it. Moons can oftentimes be fragments of other moons. In other words, they take on an orbit also. And so all of a sudden, the moon thing doesn't seem as though it's a perfect orb the way our moon is.
That's right. And not all the moons that we're talking about are the kind of moons you bring home to mom with pride. Some of them are pretty pathetic as moons go. All you need to do to be a moon is to orbit a planet. There's no size requirement. So some of them, as you say, are rather small, maybe a mile, a couple of miles across. What's remarkable is that at this great distance, we've been able to find these smaller objects and to total up how many objects are orbiting these giant planets that are at the outskirts of our solar system.
Well, it's interesting to hear you say that because I have to say I was struck by, we don't know exactly how many moons. They say, 12 more moons were discovered around you. I'm thinking, really? We don't have a solid handle on what's happening in our own solar system?
No, because things are relatively small and far away. And so they're hard to see because the way we see things out there is by sunlight reflecting from them. And the further out you go, the less sunlight there is, and therefore the harder it is to see these faint reflections from small objects. So that there must be many moons we haven't seen yet, especially when you get out to Saturn and Uranus and Neptune, these really outermost planets. And there are astronomers who every day wake up with the aim of, I'm going to find yet another moon or yet another small body out there. Even little Pluto now has 5 moons known instead of the one that we knew about when I was first teaching. So it's great.
A couple of
Kim's a
listener
fan of the
questions.
Hubble. Aren't you, a fan of the Hubble telescope?
Oh, yeah,
and its
absolutely.
its imagery.
Yes.
So as a Professor Fraknoi, Professor Andrew Fraknoi is speaking, I thought of what he's talking about, which is, our ability to see things. And the Hubble, of course, can see things into the farthest most reaches of the universe, it would seem.
Yeah.
Well, yes, the Hubble's been great, but now we have something even better. I'm sorry, Kim, you need to find a new telescope to be a fan of, because we've recently launched the James Webb Space Telescope.
That's right. You have
which
pictures
is
on your
much
website.
larger mirror than the Hubble. And so we can see even further out with this James Webb telescope than with the Hubble. Well, one of the big things we're going to try to do with this telescope is to look so far out that we're looking back almost to the beginning of time.
Oh, that's so
Which
cool.
is a mind-boggling idea. Let me just mention for our listeners what I'm talking about, because light takes a while to travel. Light is the fastest thing there is, but it's not infinitely fast. It takes a while to travel. And so the further away we go, the longer the light takes to get to us. So as we look out deep into the universe, the light we see, or the heat rays that we see with the James Webb telescope, took a while to get to us. And so we're looking back into the past. We're seeing things as they were. And the game is to see as far back as we possibly can, back perhaps just after the Big Bang, the creation event of the universe. And that's what the James Webb is going to enable us to do.
Well, Kim's a one telescope woman, but she, I think, could warm up to James Webb. Go ahead, Kim. Sorry.
Just a couple viewer questions from Calvin Wong. Why didn't these moons show up on a telescope? Why just now are we seeing them?
Yeah, so it's absolutely true that the telescopes are what we need to see faint objects. The fainter things are, the more light you need to collect for it to make an impression, not just on your eye, but on a photograph or on a digital screen. So the problem has been that these objects out there are so faint that the light simply hasn't registered with smaller telescopes. We need bigger telescopes and better light gathering instruments, much like your phone now can see things in the dark because they have such a sensitive digital screen essentially in your phone. Same way our telescopes and our instruments have gotten better at seeing faint things.
One more from Anonymous. At what size diameter does a body of rock orbiting a planet become considered a moon?
That's a great question, and we don't have a good answer. Here's the problem. Around each of those 4 giant planets at the outskirts of our solar system, there's not only moons, but rings. We know Saturn has a ring. You probably learned that in school. And Saturn is a ring that gets all the media attention. But there's actually a ring around Jupiter, a ring around Uranus, and a ring around Neptune. And these rings are made up of even smaller particles, some of them dust size. So these rings consist of a lot of particles, perhaps millions of particles orbiting in a disk. What makes a ring particle rather than a moon? How big do you have to be before you're considered your own moon? We've now found moons inside the rings of Saturn, for example, because they're bigger than the ring particles. So we astronomers are completely bewildered by where to draw the line. And we're just kind of giving up on that part and saying, well, if it's big, we'll call it a moon and leave us alone.
Well, it's an emerging science. The perfection, you talk about the origins of the universe. I tried to read this book. It's called The First 3 Minutes. And it's really hard. It's really got a lot of, to me anyway, it seemed like there was a lot of physics or chemistry or stuff. And you realize that the first 3 minutes, after the creation, the Big Bang, that was when all of these different things are happening, all these physical processes, some of which don't even exist, I think, in the universe anymore, or that we, at least on our planet. They're all going on simultaneously, and I go through all of this stuff. But the reason I mention it is when you talk about the origins of the universe, and I think about the perfection of Earth, all the stuff that had to come together to make this place. I mean, it really is an inconceivable thing how evolution had to favor so many different processes for us to get to this perfectly balanced place.
That's absolutely right. We call this cosmic evolution. And I want to answer your question in two parts, actually. One of the things that I think is really exciting that happened as the Big Bang explosion was happening was that it was hot. And it was actually so hot that the entire universe was like the inside of our star, inside of our sun today. It was hot enough so that simple particles could fuse together and make heavier elements. So the early universe was like the heart of a star. And some, for example, of the helium with which you blow up balloons at a children's birthday party, that element helium was created in the Big Bang by this heat. But then, as you say, the second part of this is that after the Big Bang dispersed and the universe, the matter of the universe began to gather together and make planets and stars and galaxies of stars, an amazing regularity and almost, as you say, perfection was able to be manifested by this random material. Gravity could pull things together into beautiful balls of gas that make stars, balls of solid material that make planets. And on these planets, life could evolve, life that eventually on Earth at least became intelligent. And through that, the universe is able to appreciate itself. We are matter in the universe, which is capable of appreciating the beauty of the universe. And I like to celebrate that idea.
So that is like almost a literary take on it. That's really beautiful. Can you explain why the Earth's core is slowing down? What does that mean? The Earth's core is slowing down.
That's a recent piece of news that geologists have noticed that there's an ever so slight slowing down of the spinning of the Earth's core. Just like the Earth itself spins every 24 hours, the molten core of metal inside the Earth also has a spin. And this is a very small spin that this is really not something that anybody needs to worry about. But geologists have just recently found it. So no, we can't yet explain what's going on.
Wouldn't you say, Professor Fraknoi, we will have incinerated the planet well before the core issue becomes something that we have to worry about?
Well, at the very least, we will have destroyed the habitability of its surface, which is so sad. Here we've inherited this wonderful planet and we're messing it up. It's really hard for astronomers to watch.
Yeah. Where did all the matter in the universe come from, asks Randy.
Right. Well, this is the fundamental question of both science and, for some people, religion. Where did the universe come from? Why is there this amazing collection of matter and energy that we call the universe? And one answer is it came from the Big Bang. Space, time, matter, and energy were created in the Big Bang. But that's not a very satisfying answer. We ask what happened before the Big Bang. Now, the proper answer to that question is time itself began in the Big Bang, so you're not allowed to ask that question. But that's not very satisfying. And so scientists and everyone who likes to think keeps asking this fundamental question: is our universe, is all that we see and can observe part of something bigger? Is there something perhaps called the multiverse, which is now getting a lot of publicity in comic books and comic book movies? Is there the possibility of multiple universes in different dimensions of space and time, of which we are just one small component, one universe among many others? And there's no way to do science about any of that right now. This is sheer metaphysical speculation, but ain't it fun? It's so much fun to think about these ideas, and that's why the comic book people are doing it. And all those Marvel movies are talking to you about the multiverse, because this is just fun to speculate about.
Our last couple of minutes with Andrew Fraknoi. I want to ask you about Mars. It gets a lot of conversation now around Elon Musk and sort of these super rich dudes who are all planning, condo developments up there and meta spas up there on Mars or whatever it might be. I always thought that, and we're knowing more about Mars through exploration, but I always thought that just even travel to Mars is prohibited because of radiation. Can you speak to just the challenges in trying to go to this place that everybody's talking about, working shuttle service to?
Absolutely, and you are right that one of the things that people are not considering properly is what kind of dangers there are just getting to Mars, because you can't just get in and in 5 hours you're there. We're talking about trips that could take months or years to travel between the planets. And during that time, you're exposed to the radiation and particles from the sun. Our star, the sun, puts out a lot of light and other kinds of radiation, but it also has a wind, a kind of blowing outward of particles. And these particles, when they hit you, it's very much like being exposed to radiation in a nuclear power plant. Workers in the nuclear power plant have to wear a dosimeter, a special badge that measures how many particles have gone through them. And after a while, they're not allowed to work there anymore. And if there happens to be a wind gust from the sun, as often happens, where more particles come off temporarily, and there are astronauts on their way to Mars, they could exceed their allowed dosage of high energy particles going through them. And they, for example, might have trouble having kids once they get to Mars, or they might find other kinds of damage, like why it is that your doctor puts a lead apron on you when he takes an x-ray, because you don't want to be overexposed to radiation. So ships will need to be shielded, and we'll need to be careful when we launch, when the sun isn't active. It's not such a trivial thing to get to Mars. And then once you get to Mars, the important thing is that there's no oxygen, and the air pressure is so low that if you were to step out unprotected, your blood would actually boil. On Mars, we are at or above the boiling point of blood. And if you don't wear a pressure suit, your blood, like getting the bends, your blood would start to get bubbles inside it from the low pressure on Mars. So
Sounds
you not
unpleasant.
have to be careful going there, you have to be careful when you get there and carry a lot of pressure suits and other equipment with you.
Wow. Well, this has been great. I love this as a little primer, or a little sampler. By the way, I have a personal question to ask you. When I knew you, and I never really, I feel like we haven't ever met in person, but I feel as though am I right? I talked to you on the radio for hour after hour.
I have the same feeling that we've talked on the radio, but I've never before seen your face. So it's great to meet you.
Yeah, it really is great. But I always called you Andy Fraknoi. And I've noticed that you've dropped, it's maybe not you, maybe, just the way people refer to you. It's now Andrew Fraknoi. I don't hear anyone call you Andy Fraknoi anymore. I always felt Andy was an across the fence kind of, that's why I liked it, because it's Carl Sagan-y, very approachable. Andy Fraknoi is here. What's the story on Andy versus Andrew?
Well, I began my career at KGO with Jim Eason, who was one of the legendary people who interviewers, and he had his own show in the middle of the afternoon. And he kind of adopted me. I had never been on the radio before. He tutored me on how to tell jokes and make my answers shorter and less difficult words. He was a great mentor. And he got to know me and started calling me Andy. And so then everybody on KGO called me Andy. So I'm generally known to people as Andrew, but I'm happy to be called Andy by my friends.
This is Casey Kasem on American.
No, what I thought was
What the
Ron
hell
Owens.
is going on in the United States of
That's
America?
the one. That's the one. But well, Andy or Andrew, it's really cool to see you again. And I must say, you again. I must say, I want to spend just a quick 30 seconds on this project, which is so special. The book Astronomy. It was published free online. Tell everybody about this book quickly and about this project, more to the point.
Sure. So this is a nonprofit called OpenStax, OpenStax. And you can Google it online. They've been funded by the Gates Foundation, the Hewlett Foundation, and others to produce an introductory textbook for every subject in college free of charge. Just in astronomy, we estimate we've saved $60 million for students in the last 6 years because their astronomy textbook was free. So I'm really honored to be the lead author on this book. The astronomy book is called Astronomy. The psychology introductory book is called Psychology. It's very simple to remember. And these are all free textbooks to help people afford the first few years of college. We like to think of our book as the first astronomy textbook with jokes because I helped write it. But by all means, look it up online at OpenStax Astronomy.
OpenStax, and again, Stax is STAX, and Astronomy. Congratulations on the success of that and your 7 fiction stories. Very cool. So neat to see you as prolific as you are, and a great visit with you. Thank you, Professor Andrew Fraknoi. We'll see you next time.
Thanks for having me.
Bye.
Hi, it's Mark, and I thought that was great. Hit the notification bell. You'll know whenever there's a new video being dropped, and please subscribe to our channel to help us save the universe.